Hi. So we already know what is the prime standard which is used for PLC communication. So now I will show you the wireless solution for smart grid controlling and the problems that engineers need to face when designing such networks. So in wireless communication for smart grid controlling, we are be using the ISM bands. Of course, depending on the country, this frequency will be different. So the most the most widely used frequencies are those three: 433, 868 megahertz, and 2.4 gigahertz. Um, But what is this ISM band? Well, ISM band is called, well, its name comes from so-called industrial, scientific, and medical band. And this is a part of the radio spectrum that can be used for any purpose without a license in most countries. So that means it's a completely free license band. And well, there are going to be a lot of different implementations, different system implementations in this frequency. So for sure, this frequency is going to be crowded. So here you can see on the slide, you can see how those bands are allocated in different countries. Um, so we can see it as for USA, for Europe. So the most common here are 433.868 bands, um, the Japan and China. Okay, if you would like to have more detailed information, I would like to refer you this link just right here. You can read about this allocations of the band from the ITU page. Okay, so what you see here is the solution for smart grid controlling using the wireless solution. So we have two different planes, which is the A plane and the B plane here. Um, what is very important here is this method of wireless routing, which is here. Of course, we are not going to discuss this solution because it's wired and it is implemented via PLC communications, which we already discussed. But we will focus here, okay? But this is just to show you that uh, those um, uh, those technologies are mixed and are used in the different locations. Um, what is special here? Well, all those meters are of course wireless, so they communicate to each other basically, hop by hop. Okay, so the network, you can add network like ad hoc network. You can create ad hoc networks, and then the meters will be communicating via hop by hop. Um, that means that every counter is a gateway and the routing node for its neighbors. So this is how it looks. Okay, there is a collection gateway somewhere at the border of the system, and of course it is being then convergented, changed to the IP cloud and routed for the to the metering collection server, which is connected with the metering control server, which is a point of the control for the metering collection server, and the metering control server is sending the information via cloud, of course, which is IP cloud, just right here to the business office terminal of the utility provider. Um, well, the major problem here is this portion. Well, it's more often we can find that this kind of communication, this kind of meters are causing a lot of damage to the environment and health. So the engineers will be probably sooner or later will be trying to develop some lowering emission, electromagnetic emission protocols or methods, because well, it will be impacting our lives really bad. Okay, so just to organize what is the responsibilities of the sites we saw on the last slide. Well, the A side is responsible for metering and data collection. Of course, control of that. The creation and distribution collection route maps, which is this is of course made by the metering data control server. The remote control operation, that means that the servers can uplink the new information like tariff, for example, or block the tariff, etc., etc. Data processing and receipt for other business systems. So the B side here is responsible for collection of individual house meter readings. So every meter is just is responsible for collection the data from each home and transmitted via hop-by-hop wireless communication. Downlink data transmission. So if there are new, for example, tariffs or whatever, changing the tariff, the meter is downloading it from the network. The data routing is a multi-hop method, as I mentioned before. Of course, it's bidirectional, so both receiving and transmitting. And here is also the meter reading data retention. Okay, well, we just grab some knowledge on how those two topologies, two solutions can work. But here I would like to familiarize you guys with the problems that can be that wireless communication can create, especially in a crowded environments. So to give you a good feeling of what I'm talking about, I decided to draw you a diagram which represents the network. This is the wireless node with its radius of transmission just right here. So those blue circles are describing the radius of the transmission. So if there is a radius of transmission, there is a first problem that we are facing, the engineers are facing. So the limit range, okay? So the communication needs to be organized in a way that every node will see at least one neighbor to be able to sending information properly to the utility provider. The second thing for the wireless communication is, of course, for the wired is also there's this problem. It's a common problem, but for the wireless it appears more often because there is a problem of the air interface. So the second problem is the transmission errors. Those errors will occur in a different from different circumstances. For example, bad weather, your neighbor just parked a big car in front of your meter, etc., etc. So there can be problems with the communication. So the engineers need to resolve also this kind of situation. So these two major, I would say, major problems are faced when implementing the wireless routing methods for example, smart metering. Okay, so just to summarize this short video, I just would like to present you the pros and cons of the wireless routing methods. So first of all, the pros is that no cabling is necessary for implementation of that. The multi-hop communication provides you a quite good reliability of the network. So that means that the meters the data need to travel only short distances, not like a long distances, and they can be lost or even very, very highly errored. It's just it is implemented in a way that it's a communication hop by hop to the next neighbor. Uh, of course, those methods can use the correction codes to improve the reliability of the network, which is very common. And of course, the correction codes can eliminate, for example, the problem of the method of one of the methods of hiring the reliability, for example, making it retransmissions in the network. But when we have an unlimited source of energy for the node, it is not very necessary to think about it. And of course, low operational costs for the meters. So the cons of the method of wireless method is undoubtedly the high interference in air interface medium. So this is the problem which I told you on this diagram, that different obstacles can create different behaviors of the network. The second thing is the health problems. So the high microwave emissions can cause environmental and health problems, which is already raised in US pretty widely. Um, this number here is just to show you how many transmissions can be made by a single node for the single wireless node working, for example, in a 868 megahertz band. So it's almost 200,000 per day. So you see how big emission, microwave emission, is caused by these nodes, and it's for sure not healthy and not good for the environment, and can cause health problems. And of course, the limited range. The limited range will cause the problem of errored messages. And creating more sophisticated methods of routing. Okay, thank you. This is all that I wanted to show you in this lecture. I hope that it was interesting. Thank you very much, and bye bye.